feedback is Forrest Pittman, and my name is John Fiala. Forrest and I have a unique relationship with Paul Pantone. Before he was detained, we were already helping him with difficulties, legal difficulties, and we had arranged for to be able to provide for a way so that he could continue his work without interruption when he was detained. What we're going to do is we're going to try to go over technology, the basic principle of the technology. We're going to go over specific applications, and then a little while later, one of us is going to go get a working GEET motor, and we know it worked because it may have worked sometime very recently. And then what we're going to do is we're going to take questions and answers. Now, if you have something that's very serious, like, John, the building's on fire, Forrest, the floor's about to fall off, then we'll take questions. But for everybody's benefit, I know you got your hand up. If it's a fire, then you put your hand up all the way. But if it's not a fire, okay?
If you put your microphone as low down as his is, then it won't be.
Oh, no, we have to have his up. His has to be a lot higher.
No, his is fine.
Well, it's otherwise what happens is we have to turn it up. See, those people can't hear. Okay. Okay.
Pass that into us, would you?
Okay. Here's the rest of some more of the GEET hardware. Okay. Actually, I don't know how you can, if you guys can all see these, but the basic concept of the GEET is that you create an electromagnetic field that is a reduction oxidation field. Okay, in chemistry, and for most of you that have chemical backgrounds, that's very, very simple. It's where you're breaking a bond and you're recombining a bond. So sometimes what happens is that you break the bonds on one part, on two different molecules, and then they recombine for new ones. It's like when you make the silver on a mirror. You take a silver nitrate and potassium iodide, and you mix them together, and you get silver iodide, and that's what makes the front surface mirror, and you get potassium nitrate. And it comes out in white particulate. Well, what's happening here is that we create an electromagnetic field. At this case, we're flowing air, much the same way it happens in a cloud, over a metallic rod, and we're developing a static charge. And Forrest, the moment anytime you want to jump in, go ahead.
They probably wonder what the static charge is derived from. Well, iron has inherent
Okay, now what transpires is that over the rod, much like the clouds in the air, what happens is that this rod, I'm going to grab one of these. Okay, is the mic coming in on the...
Your mic is fine, but
Force is not coming in? Okay.
1, 2, 3, 4, 5. Can you hear me?
yes, now I can.
Okay.
Okay, good. Thank you. Anytime there's a question, go ahead and... let's see. Okay, here's a rod. What happens is that, like anything, if it develops an electric charge, we want to keep it from grounding out. This thing can have an electric charge, but if you have it grounding out, it's touched to earth ground or anything that you can dissipate the charge will never build up. So what happens is that the first thing that's very important is that in the tube that constitutes the GEET reactor chamber, we want the tolerance to be less than a 32nd of an inch. If you can do a 64th, that's good. Now, you may ask, well, John, what's the difference? Well, the difference is how much flow of a vehicle are we dealing with? Are we dealing with a little 5-horse Briggs & Stratton, or are we dealing with a 500-horse Chevrolet big block 460, you know, or 454 bored out to 500 that produces 500 horsepower? And see, remember that that gap between the reactor rod and the housing is where the flow is going to pass through that's going to give you your fuel air to your engine, okay? So what happens is that you have to have enough, or satisfactory enough, cubic feet per minute, CFM capacity, between the tolerance in here. Now, the best place, now this rod right here is a very nice piece of rod. This is an extremely excellent piece of rod. This one, and the reason I say it's extremely excellent, it doesn't have a seam in it. Now this one is actually EMT conduit, okay? But it does. But the thing that would make it excellent, now I don't really recommend using EMT conduit, but the thing that makes a piece of tubing excellent is there's no seam in it. All normal pipe that we get, like the black pipe for your gas, you know, in your house, your galvanized water pipe, all is made from a flat sheet of metal that's rolled and butt welded. And on the outside, they always grind it clean. But on the inside, there's that seam. You know, when you stick your finger in, you can see it. 1/2-inch rod fits inside of a 1/2-inch water pipe with about
11/64
of an inch clearance, okay? So basically, 0.06, is that 0.068 or 0.065?
41/64.
Okay, yeah, so what happens is, and that's the 41/64 is the ID, and 32/64 is a 1/2 inch. So what happens is that there's enough of a gap that usually when you use like a 1/2 inch black pipe or a 1/2 inch water pipe, you got just enough clearance for most smaller engines and even some larger engines. Now the idea here is that when we start to, we're drawing air in, and what we're doing is we're creating, there's all kinds of study groups on the internet, like a vortex generator, you know, and how many of you have a Yahoo group ID? How many of you are familiar with Yahoo groups? A large portion of you, excellent. Well, there's one called Vortex Generators, and there's quite a few other groups like that that are just fabulously dedicated to GEET. If you can get on the GEETfriends.net site, they reference a lot of these things. But what happens is that the air flows in here. We have a tight enough clearance that this thing, when the air's flowing, it no longer sits on the bottom. What we want it to do is the air to circumferentially flow so that this actually floats right in the middle of that, so that the airflow is sufficient and fast enough that it homogeneously makes that float circumferentially within the reactor tube. Okay, now, to augment that, we have to do two things. One of them is, if we just have a flat blunt end, or if we have a hollow ground end in the air inlet, it's just going to push that thing to the back, and it's going to plug the hole, you know. That's not going to go over very well. It's not going to work. Let's not do that. Let's put a nice radius on here, a 1/4 inch radius, or on a 1/2 inch rod, it's a 1/2 inch round over. You know, Forrest can machine anything. He cannot just machine anything. He can do it mobily. He's got a huge step band that is probably the nicest machine shop I've ever seen on wheels. And he can turn this stuff out in his sleep on the road. I could drive, and we could go from here to there, and he could build a whole GEET while I'm driving. I mean, while I'm sleeping. But what happens is that once this thing is hovering in the airstream, and we've got a nice circumferential airflow around it, what happens is it develops a static charge. Isn't that interesting? And now, as it develops a static charge, it develops an anode and a cathode. And as it does so, it creates a reduction oxidation, and is with an anode and a cathode. One is exothermic and the other is endothermic. So one of them, the exothermic end, the inlet, is going to become very, very hot, anywhere from 270 to 490 degrees. It'll get very, very hot. Actually, some people have measured temperatures in the excess of 600. I haven't personally measured that. optical thermometer. It was the best shot we took at it. The other end becomes extremely cold. In some cases, it's as cold as facing north. We even was leaning up or down. It's eventually rods that face perfectly straight up and down. They're non-polar. Frustration. We lost that puppy. Unplug it. We need to just get the technology of cell phones back, you know. Hopefully he'll be able to call back. My humble apologies. It had to be renewed since he bought the vehicle. He's changed it so that it looks like a radiator hose, one of those Prestone service fittings underneath the hood, you know, where you flush it out. It looks like it's got a little cap on it. And now that fills the tank in the back, and when it comes gushing back out the other side, it's full. You know, so that, you know, opening up your trunk and pulling in there and the water hose, you know, everybody kind of looks at you and scratches their head. And it becomes something that could be a nuisance. The best security for something that you don't want people to find out about is ignorance. I didn't tell you that this is not really a plastic fork, but it's gold that's been painted black is powder painted gold. Not really, but if that was the case, if it was gold and it was just powder painted black, this nice color so it looks like a plastic fork, I could leave it there for weeks. And every inconsiderate person that would not clean up the room would leave that silly thing right there the whole time. And somebody knocks it off the floor and actually gouges it, and all of a sudden there's a shiny gold. It's too much beyond their belief. That's too absurd to believe. And often, you know, or they throw it back on the table and there it sits for another 2 weeks. But if you tell somebody, I've got a gold fork and I'm going to paint it black, and I set it up here, and you could put 8 big tough guys with, you know, good, you know, heavy artillery and crisis management tooling, and, you know, and 24-hour around the clock guard and 4 feet of bulletproof glass around it, and somebody will figure out a way to take that away from you. You know, so your worst enemy is right here. You go start telling people about this and you're very proud about it. It's like defending a patent. Patents, the defensibility of a patent is equivalent to your wallet. You know, defending a patent, you can have a patent, you can have your name on it, but the moment somebody infringes upon it, if you don't have the money to pay an attorney to come after the people that have infringed your patent and get you your rights, that patent is useless. Okay, so just remember that. Oh, you know, ignorance is the best security you can possibly hope for. There's a lot of good reasons to get patents. Don't misundertake me. Okay, just understand that, you know, there's at this juncture, sometimes driving a vehicle, especially if you live in Tennessee, they like their road use tax, and that really bothers them. And in certain places, and especially in Nashville, if they find out you're driving a vehicle where you're not quite paying the correct ratio, even when we had that ethanol tax incentive credit back in the 70s and early 80s, that was the federal government, that you could, you know, if you produced ethanol, you could get the incentive tax credit. In Tennessee, they put an extra tax on it, so they were taking the equivalent of what you would have gotten off your tax credit for the state. That's how wonderful those thoughtful citizens are. But there are other jurisdictions like that. We're not going to go into that. After you figure out what size your rod is, grind yourself a new one, go install it. This gentleman that has the Lincoln Town Car, he did a very, very good job. He's getting about 61 miles to the gallon with his Lincoln Town Car. He has he's using the original computer. We have jumpers from the injector cables we're injecting into a special mix tube. That was the first, it was the first guess my best kind of experimental we had him go to the junkyard and get some electrical harnesses off of Ford. He bought the new injectors from the auto parts store. We created a mixed chamber that takes the place of the bubbler. He uses a high pressure fuel pump. It's the one that they normally use in the Jeep Grand Cherokee. It's the intake pump. That's 110 psi fuel pump. He runs the injection system on that 110 psi pump. It's great emulsification. We have it heated. The chamber where we mix it is heated by exhaust and by radiator coolant water, because anytime you evaporate of fluid, where does the temperature go? Does it go up or down?
Down.
Down. Okay. Does liquid burn? Right. Only vapor does. Okay. So when we're working with a bubbler, if we have a higher atmospheric pressure or a lower atmospheric pressure, which boils faster, higher or lower atmospheric pressure?
Lower.
Exactly. In your bubbler, we want to create a lower atmospheric pressure. We want to create a restriction on one end. That's why we have the inlet valve to the bubbler. 11.6 inches of mercury is where it turns out to be about the minimum, vacuum that you want to have in your bubbler. And some people say, well, John, look, I got a manifold vacuum gauge right on the center console of my car, and it idles between 22 and 26, except when I've got my foot through the firewall into the transmission bell housing, then I only get about 14 or 12. Well, that's true. Your manifold vacuum better. But to get the water out of liquid into a vapor solution so we can get it into the reactor chamber so that we can get the reaction going, we first have to get it out of the bubbler. Or if we're using fuel injection, you can, high injection misting, you can do that, but eventually if it doesn't turn to a vapor, doesn't evaporate, what happens to it? It puddles in the bottom, and it's not going to go anywhere. And a lot of times when you have a GEET motor and there's, sir, I've tried this and I've tried this and I just can't get this to work. What's the vacuum like in your bubbler, sir? Well, I hadn't really checked that. Is that important? Well, yeah, actually it is. So can you get a manifold vacuum gauge? Something that goes at least up to 25 inches. There's Amflow makes one for $11. It's a 3-inch gauge. It goes 0 to 30 inches. Works really great. You can go buy the rubber tip nozzle from the Amflow blowgun and get yourself a 1/8 female coupler and just put it together and just drill yourself a little hole in the top. Especially if you're using a mason jar, drill yourself a little hole in there and just put that rubber stopper on there, and then just see how much manifold vacuum is while you play with and you'll find that the higher you can get that manifold vacuum, the better that will run. Because what's happening is you're getting more, while this is bubbling and turbulating, you're getting more of the water than you are
Gasoline.
exactly. And this is what we're after, right? We're after getting the water. If you have extremely low vacuum, all it's going to do is take what? Just the gas. There's the fuel. It'll take the lighter element. In this case, it'll just take the fuel. You're just, and what they call is what's called fractionalization. And some of you have been on some of those Yahoo study groups. You've heard the term fractionalization. That's an oil industry refining term. Am I talking too fast? Can everybody hear me okay? I want to make sure I'm looking. I haven't seen any test patterns yet on anybody's monitor there. I've seen a lot of the headlights are on bright. That's a good thing. Nobody's been doing touch and goes yet on the runway or so it must mean something. It's not too hot in here.
Hey, John, why couldn't we pause and let a few of them ask us some questions on the rod that we haven't?
Okay, well, how about if we just finish up with this one?
Yeah,
okay,
I'm
okay.
projecting.
Now, what happens is that vapor, when it comes in and works around the rod up here, what Forrest was saying, now it also spins. Anytime you have a ferrous, any type of ferrous material spinning next to other ferrous material, what do you have? Another electromagnetic field, exactly. Yeah, it's the same thing. So what's happening is that first we're developing a charge just from the air, from static. We slowly get a discharge there. We're getting a multiplier effect that every time one discharge goes one direction, the electron flow, it creates an electromagnetic field in the other one, so that we're getting these constant electronic discharges, and it becomes so violent that it develops what's the field?
Glow.
Yeah. And so what happens is now this creates the environment where we have our exothermic, endothermic reaction, that in the exothermic end, it breaks down all of the elements that are coming into their basic components on the periodic chart, and at the endothermic, And what was it? When things become endothermic, what's happening? We are breaking or joining bonds. Right. And that's where the materials become combustible. Okay? And that's where based on
it homogenizes them by mixing them very thoroughly.
okay.
So they're not the same element anymore.
And what happens is that it's our suspicion with Paul that the material that's actually coming out the other end doesn't even match a petrochemical. One of the reasons why we believe that is because last night when we were running the other motor, I could hold my hand there. There was no residue. The only time we smelled anything was when John was in there trying to, that one normally takes 4 pulls, because when it's just sitting there, any combustible material just slowly evaporates away or settles out, But, when you pull it a couple times slowly, it makes its way through the length of the tube, and then finally it makes it in the cylinder. And then when you pull it, usually on about the 4th pull, Dennis was right. On the first pull after we got, for those of you who were there last night, after we got out of the rain and got into Albuquerque and everything else, and that thing was flooded, the first real pull that I gave it, it fired right up. I can't explain that. It was neat. It was very cool. Okay, basic rod questions. We're going to take about 5 minutes to do Q&A. Charles.
2 questions. One, I already have the
Testing. Hold on a second, Charles. Testing 1 2. Testing 1 2. Okay, Charles. Pass that to Charles.
yeah, John, I have my tube installed, my tubes. I'm doing a dual system. I have them in the exhaust pipe, but I never realized I had to machine the inside of that. I just used regular half-inch gas pipe. Is that critical?
Yes.
So I have to pull them back out and machine it? Just get-
Make your provision to pull it out.
Well, I do.
What you might do is to do it by hand machining. Get you a piece of rod. Doesn't have to be perfectly round. Saw your slot in it. Get some crocus cloth and wrap it around until it's tight fit. Put it on your electric drill and just move it back and forth in there until you polish it. And that should take most of the high spots down to where it won't be a problem anymore.
Okay, and the other question being, on my, the steel rod that goes inside, I just ground the end off with the grinder. I didn't machine it. I didn't realize it had, haven't got that far yet.
You might take and put it on an electric drill and then take it over to the grinder and then do a light touch, and that'll make it a little truer.
Yeah,
Otherwise it'll make it out of balance.
That is so fabulous. You take this half-inch rod, and most hand drills are what diameter, Chuck?
3/8.
Yeah, a lot of the lighter weight ones are 3/8, but most of them are half-inch. You just chuck up that half-inch rod in there, and you go over to your belt sander, your grinder, your disc sander, and you just kind of manicure that thing. And you can also just take the belt sideways and just kind of clean that thing up, and it looks real. That's what makes it look really good.
That's basically how I did it on the lathe.
The rod itself has to be machined.
No, the cold roll works fine. I just polished it to make sure I got any dings or dents or imperfections off of it. I used a couple of old punches for some of this. And, oh, yes, sir.
Question. Is it best to have the rod just be straight and smooth, or since it's spinning, should there perhaps be improvement with a spiral groove?
If
Or
it's smooth to the touch, straight and smooth is fine.
okay.
Yeah, it don't have to be to a mirror finish.
John, I changed my drawing a couple of times here, the north and south. You said that the round end was north.
It'll vary sometimes. Sometimes it'll swap polarities, strange as it may seem. And that would probably be because of the way you have the machine orientated when you crank it up.
Well, now,
That's rare, but it does happen.
what's the process for finding the length of the rod again with the
So you
with
take
a
small
compass?
and you start at one end of the rod, and then you work toward the center, and then the hand will turn on you, and then when it turns straight up and down on it, lock it with a felt pin, and then go to the other end of the rod, bring it back in, and where it turns up again, that is the node. And then you can get you another rod and saw it off to that length. There might be a little space there, but not very much. It'll be pretty close.
Okay, thank you.
That'll give you your rod length for the fuel you're burning, or burn that in at the time.
Forrest, I don't hear you on the mic.
How's that?
Can,
Not yet.
Keep yours disconnected.
Can you hear me now?
Those are, yeah.
Question, when you say the rod starts to rotate, in that configuration, can you tell, is there a preferred direction of rotation?
No, you don't even, you'll never know which way it rotates, because
So-
you can't see it.
So, well, I mean, if, say you made out of glass and you put some, a red spot on it, then you could tell which way it's rotate. Are you saying that it could rotate either way, or does it have a preferred direction?
It would probably be preferred direction according to.
And so-
magnetic field on the
So,
whirlpool will go a right-hand spin in the upper hemisphere and a left-hand spin on the lower hemisphere.
Okay, when it's facing north, what it'll do is it'll rotate counterclockwise automatically if you burn it in. And once it develops that signature, it'll always go counterclockwise. That's the way when it's facing north. If you burn it in facing south, which is less, it'll turn clockwise and it'll spin clockwise. It does develop a memory, and it always goes the same way once it's developed a memory.
his question was that, would a smooth rod be better? Or would, if you had a spiral groove in the question, aligned with the direction of spinning?
The spiral groove at this juncture, what it does is it allows for more airflow and a dynamic instability. And what happens is that it's almost impossible to put a spiral groove in there that will spin dynamically stable. So actually grinding grooves in it is actually discouraged. I do know one or two people that they're excellent machinists. They have CNC machines, extremely good at it, and they've written programs for lengths and on their experiments. And what happened was that they believe they've done a good job with a spiral groove. That's extremely hard, and they even question their own capacity whether they did a good job.
I was wondering how you link the rod to the car that you're making.
Well, you start off with a longer rod.
But how does it know it's a Cadillac or a Volvo and determine the length? I haven't seen the connection between the rod and the car yet.
Okay, that's a good question. What happened was earlier, where's that big 13-inch rod we were playing with a little earlier? Or actually, here's something that would right here. What happens is that regardless of the vehicle, the rod has a specific vehicle. What happens is that take a 12-inch piece of 12-inch material and burn it in, make extra long, and then take it out. And when that compass, when you start at one end and the compass begins, and it's purple, draw your line on there, and you start at the opposite end, or you just keep going, and once it swings again and gets ready to, you mark that again.
That then it must be related in the that your car is involved in that.
Sure, you burn it in on the
On the
car
car.
that you want.
On the car, yes, yes.
Yes, you burn it, yes, exactly. You burn it in on the motor, I'm sorry, I didn't make that clear. So, somebody pass this back to, okay, all our Q&As, if you can wait till you have the microphone, way everybody can hear you, and it'll be on the recording.
Would it be any advantage of putting electric magnetic field or a permanent magnetic field to primarily
Artificially magnetized,
to begin with?
we have thought about that. We haven't got to the place where we've experimented with it yet. We've done it, all the rods so far have been done. Was it that EF, or we done it the old-fashioned way? We worked for it and we earned it. We did it the hard way.
Thank you.
Okay, the gentleman next to you.
Yeah, John, could you clarify the use of the baling wire? That wasn't clear on that.
Okay.
Your call.
Okay. Okay, we'll just push it right there and we'd already lost it, drat. How frustrating. Okay, hopefully he'll try to. This is Rocky.
Hello?
Okay, brother. Hey, thanks for calling back. Okay, we were wondering if you could be over that burn-in on the rod again.
The flat end that is concave is the pointed end is the south end. If you orient the engines that's the direction it is, or the north end can also be straight up, biblically speaking, straight forward, flying it all the time. You run it for about 30-35 minutes, break in a lap, then let it cool down, out of and check it with this. The rod from the east to keep you directly from the west. This way it'll show at least a 90-degree turn this needle to show you exactly where north and where south is. Where north is, put a little black mark or a top-end mark, and then go to the south and do the same thing. You'll see exactly how long the rod wanted to be for this cube that was just used.
Okay. And the reactor housing diameter for different size motors. Want to cover that one?
If you're talking about people who bought it for the automobile, then normally we would say that you use 2 half-inch rods with clearances about a 16th of an inch, or you would use 1/4 inch rod into slightly bigger than that for clearance, but not quite an 1/8 of an inch. It's just a nurse.
What a character is.
Why we didn't mention that this was a class.
Say it again.
And describe to the class why we did this meeting.
You know what? I didn't hear. I couldn't hear you. Where's the snow cone? Where's the cordless? Okay. Now, did you have a question, real quick?
Yeah.
Oh, we had the twisted wire one. Okay. When the phone. In just a moment, I want to pass you out the microphone, Rob, and we want to. Because I'm sorry, we just can't hear you. So, okay. Now the twisted wire. Okay. Baling wire. How many of you have Home Depot hardware store? Okay, it's soft, you can bend it and twist it. Well, if you take 2 strands of it, and just have somebody hold, back off 2 pieces about that long, either clamp them up in a vise or, have a vice grip, and just sit there and just start twisting this stuff and just start backing up, and so you have a nice twisted, or if you have some of those really cool aircraft safety wire twisting pliers where you can just go zip, 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 and make a nice twisted.
Even a piece of welding rod would work fine.
Yeah, the very thinnest welding rod is the best. But the reason why the baling wire works really good is it twisted, it's malleable. And as the rod begins to, vibrate from the oscillations of acceleration, deceleration, from the pulses, from the piston going up and down, it begins to bump it back and forth and it slowly compresses it out of the way. And you tack the 2 ends to the elbows. Tack them in there. That's also helpful. Most people don't. A lot of times, most people I know, they put it in there and they bend it around the corner, around the elbow at the end, so that it just doesn't go any farther. And then when you assemble it, they just compress it up against the rod, and the rod slowly works it. But the baling wire is just a soft, malleable opportunity device that helps hold it in place until it develops a magnetic memory and begins to hold itself in place inside the reactor rod. Okay, next.
If the rod has to be a particular size in order for the fuel that you're choosing to burn, say water, mostly, then how do you burn it? The rod being that size, does it work with it long also? Or?
Well, okay, it doesn't work near as efficiently. In fact, paraphrase, understand your question. You're asking if this is the rod I'm going to end up in, what am I doing putting a rod that long in? Okay.
We're stopping tape in the middle.
You want to stop tape for a second?
Well, we're at the point where we're stopping in the middle of the show. usually have to change tapes.
Okay, go ahead. Let's take a 5-minute break. We're going to change tapes real quick here, and then we'll come back in 5 minutes. Because actually, I need to run next door and grab something else to demonstrate. You know.
John, when he calls back, could you ask him?
Pardon?
When Paul calls back, could you ask him what he can do about this? Title for the truck and.
Now, did he do the modification on this?
Paul built this whole thing.
Okay, hold on a second. Okay. Grant me a moment's grace here. I'm just gonna, and I'm gonna. Okay, go ahead and hang on to it. Okay. I want to thank everybody for your patience and your graciousness. I apologize. Okay. Right now, the first pull, when you pull these things, it's good if you instead, on these you don't prime them per se. You don't have to. If the first pull on these, if you close the air valve first thing and it draws some of that rich mixture up into there, then the second one you open the valve and then they usually start. Sometimes, I've just left the valve in one place and it starts on the first pull, but usually I close it, and then open it a little bit and this is Rocky. Yeah, did you hear all that noise in the background?
Well, first thing wrong with me, the other one has to get down with on the other one, and this will be my last call.
Okay, I'm not moving from where I had it because I can hear you real good right now.
Okay.
Okay. Actually, tell you what, I'm just going to give you the floor and you can share whatever you want to share to the family.
First, I was going to address some of your questions on that.
Okay, I've got one gentleman with a question that he's got a motor that you had personally built apparently. He's even got photos of it. I said that he's been having some trouble getting it running. He had the photos. I don't know where he's at the moment. Actually, here he is. What was your name?
Art Achenbach.
You want to come on over to the phone?
Sure.
Okay, go ahead, Art. Ask your question.
You sold this rig to Eric Phelps back in Newmanstown, Pennsylvania, and he's looking for a title for it in the franchise that you promised him for the 70 grand that you charged him. And this truck doesn't run, and he'd like to get this thing moving.
Did you get that, Paul?
No, I didn't.
Okay, there's a truck, and this is a diesel, right?
Cummins.
There's a diesel truck that he sold to who?
Eric Phelps.
Or Eric Phelps. That it looks like a 671. Is that a 671 there? It looks like a Detroit 671, but
it's a Cummins.
Or a Cummins. What was that? A Cummins 8.3? It's a Cummins diesel, and did it sit for a while?
Yeah, it's been sitting for a few years.
And they were just talking. Actually, you know what? This one, this isn't to get this restarted. We've got to look at it and figure out the bits and pieces of why it's not running, and look at it, because it could be something as a loose hose, something as simple as a loose hose. Because Paul, when that one went out, was it running?
Just lost him again.
That was. That's another thing, guys. Please, Ben, thank you. When your GEET motor doesn't work, a lot of times, many times it's something extremely simple. And what Paul was saying about the simplicity of it is a function of the fact that one gentleman, his rubber hoses that he was using at both ends, one of them had a crack in it, and the vacuum, so the vacuum that was coming to the bubbler before the hose cracked all the way, at first it had fairly good vacuum, and then it began to depreciate. And so what happened was that the moment the vacuum began to depreciate, the bubbler didn't work anymore, which was obviously critical to the success of the GEET. Now this is what's called an open loop or open cycle GEET conversion. We take air in from the outside, we run it through the bubbler, we run it through the reactor chamber, and then into the intake. It goes through the engine, the expent gas comes out, it goes through the outer portion of the chamber, and then to give us our heat and the remaining electronic charge that we need, and then out the muffler. But there's what's called a closed circuit or a closed loop GEET, where what happens is that, excuse me, I'm standing in front of the camera, I shouldn't do that. There's a closed circuit GEET where the exhaust is actually turned back onto itself. And certain GEETs that have been tested with a COHC meter, you're not using really the HC per se, but like if you have an oxygen meter, some of them, we're breathing an average of between 17.2 and 18.3% oxygen, depending on where you live and how much foliage there is. Okay, what's happening here is that on some of these GEET motors, because we're breaking water, remember the exothermic end and the endothermic, what's happening is there's some elements that are left over, it's excess oxygen. There's more oxygen required than necessary to join to combine with the other molecules that are being oxidized. And oxidized is the function or the term used when anytime you add oxygen to another molecule. That's oxidizing. If you add O2 to Fe, you're creating ferric oxide, or rust. Okay, anytime, and that's oxidation. That's also called rust. Oxidation, when you hear the space shuttle, the propellant, they call them, one of them's the fuel and the other's the oxidizer. And sometimes it's just regular oxygen. Sometimes they've got a variety of different components that they use. But on many of these, the oxygen content that comes out of it is higher than 21 and 22%. The first time that I ever saw Paul run to a small group, there was about 40 of us in a conference room that was about twice the size of this one, and he ran the thing for a while, and the oxygen content, one gentleman had an O2 meter. It went from 17.1, which was kind of low for ambient, but there was 40 space heaters in there using up oxygen that didn't have good flow. But when he got done, it was at 20.2%. We're still doing good? Pardon?
He has a problem.
Can we pause?
Should we want to pause for a moment? Okay. Okay, I tell you what, we're going to pause for a short break, and if you want to look at this is an open circuit, but you can, on the ones, and we'll start back on closed circuit after we get back in there, and then we'll cover the outside chamber, okay? By the way, that probably is a teeny bit warm. We'll run it right now. Should we spin the motor?
Yeah, how much petroleum versus...
Houston couldn't get the thing.
Okay, we're rolling.
Okay, there was a question, a comment here. Forrest, somebody commented about diesel. Does this work with diesel?
You bet.
Well, if it runs with crude oil and waste oil and Pepsi Cola and rat pee and, do you think it'll run with diesel, anybody? Is there any clues? Yeah. Now, let's ask ourselves some questions. Originally, when the internal combustion engine was designed, what happened was that they had a petcock valve that there was a downdraft pipe that they had a little spout that was in there, and they opened the petcock, and when somebody was turning this big flywheel, there was this pipe that turned 90 into the inlet there. What happened was they controlled it by turning that valve, and they got it to run a constant speed. Eventually, we figured out that with the butterfly and vacuum and differential pressure, we could have a float bowl that when you open the port on it, they changed the vacuum ratio in there, and it dropped more fuel into it, and the wider the port, the more fuel dropped in. And the way we did that was by the velocity of the air flowing through the boost venturi in the center of the carburetor. Okay? We figured out how to meter it just using differential pressure, so that it was so sweet and so accurate that until fuel injection came along, we'd gotten pretty close to almost like 71% efficiency on a differential pressure carburetor. We're working on that. Now with fuel injection and a feedback system where we have oxygen sensors, we can meter the fuel extremely to an extremely finite level. With GEET, we're not at that level yet. We're still at the drip it with the manifold thing, and we're doing our experiments right now with the first computer controls. The Lincoln Town Car that was just done was the first one that was all injected, had an experimental system on it, everything. It's the first success. There are 9 other vehicles out there that we have been working on for over a year and a half, coaching these people with, that are still not done, okay? So we're still figuring out, and finally I'm getting pictures from some of them. We're sorting out what's wrong. One guy was the kind of tubing he was using. He just wasn't getting enough differential pressure in the mix chamber, but we're not even close to it yet, okay? Solid malleable, see, where's Mr. Pointer here? Malleable iron, okay, on the rod, okay? Our input gases and our output gases. I'm going to go through these slides fairly quickly because we're cramming a lot into a little here, but we've kind of got a bit of a background so that now we can begin to look at some of the slides and you have some clues. Normally, this is a week-long course, what we're doing in 2 weeks. We're going to go through all the slides that normally are done and fully exponentiated in a week-long course, okay? And by the way, these slides, you're the first group that's seen these slides in their new configuration. Nobody's seen them since Paul was detained. Yes, sir?
Back to tuning the rod length to the particular engine. Do you tune it to the fuel or to the amount of airflow required by that particular engine?
The diameter, remember what Paul said, remember what Forrest said, the diameter is a function of how much airflow you have to have. The more airflow you have to have, the greater the clearance. The length is a function of the fuel and where that engine wants to run it at. And based on the fuel and the flow, remember what we said about marking the rod and sizing it and having the compass and swing it? Each engine will size itself. To date, Paul has in his head formulas that he can apply to about 24 different motors, but realistically, we haven't got a full quantitative database yet to do the monkey motion, lock knee step, math grid. This would find this is your rod length, this is your diameter. Haven't got that far yet.
But you don't need to try to tune it to cut it the length that's going to be at highway speed versus idling.
Highway speed versus idling is a function of diameter, not length. Okay. Length is a function of the fuel that you burn it in on. Okay. This is some of the these are some of the frequencies that occur at the exothermic and endothermic ends here, and some of the trace materials that remember we said we were breaking bonds here. But he's been running, it's the only vehicle we know that's been running on straight water. It's a Chevrolet, for those of you who are, I know the next question is, what has he got? It's a Chevrolet 350 4-bolt main, 8.71 to compression, to 1 compression with a turbo 350 behind it, and a 12-bolt rear axle. Okay.
Can you announce that everyone that's got a DVD set that's paid for, they can come see me? I've got all the things laid out, then I can give them their set before.
Okay, if you have a if you have a set of DVDs that are already paid for, go ahead and you're free to. They're going to wrap up. Go ahead and go get them. I'm going to stay for just a few more minutes, and we'll finish answering some questions. It'll be on the DVD. But to get your set, you should go grab it right now. But we're going to finish doing the short lecture here, so that you guys can get your DVDs and be done with it. Okay. Okay.
Can we get Paul
We're on the tape.
address and send him a birthday card?
Yes. Yes. Anybody who wants Paul Pantone's address here, hold on. I'm going to get that. I'm going to pull it up for you right now, and I'm going to put it on the screen. Okay.
Okay.
It's so that way you can. Okay. Okay, you see the address there? Okay. The top left hand there, Paul Pantone, care of Utah. Well, don't put care of because that gives them the right to open the mail if it says care of. But Utah State Hospital Forensic Unit, 1300 East Center Street, Provo, Utah, 846. 03. downset height. Okay. Okay, has everybody got that?
Not quite.
Okay, I'll be happy to wait.
One quick question. Does the packet cover diesels?
Pardon?
Does this engine packet cover the diesels?
No. The basic concept is there in all the plans. It varies from fuel to fuel and size to size. But the basic concept, once you've mastered that little engine outside.
It's about diesel engines, not diesel fuel.
Okay.
It's talking about diesel engines.
Okay.
John, could you read the address one more time for them, just to finalize?
Paul Pantone, Utah State Hospital, 1300 East Center Street, Provo, Utah, 84603 dash 0270.
You left out forensic unit.
Oh, okay. Paul Pantone, forensic unit, or excuse me, Utah State Hospital, forensic unit, 1300 East Center Street, Provo, Utah, 84603 dash 0270. I didn't have to look at the screen to remember that.
Send in birthday card.
Send them birthday cards. I may have written one or two letters to them. There's a.
Actually, John, we have 40 minutes, so
Okay.
go for it.
Okay. Continuing on. Okay. Okay, we covered it. Okay. This is a short discussion on the transmutation. We're not going to go into the transmutation of elements much more than to say that the valence amount of trace materials that are just in the air alone, there's nitrogen makes up the bulk of what we're breathing right now. At 68% plus 17%, it's between 17.8% and 18.3% oxygen is your average ambient level, and then the remaining between 5.2 and 6.3% of that make up the trace minerals, including helium, nitrogen, and including some inert gases. But this is a situation. This one was a crude oil burn that was set up, that was made and used to run a diesel engine, because you can put, the reason why you don't put fuel in the intake of a diesel is because what?
It's injected.
Well, why is it injected?
It doesn't burn by itself.
Well, anytime with an increase in pressure, you get an increase in temperature and a decrease in velocity. That's Bernoulli's principle. The reason why your car's engine pre-ignites or detonates is because as the piston's coming up, you ever put your hand on the top of the air compressor in your shop or somebody else's shop, and you felt how hot that was? Well, anytime, or the air conditioner before it goes into the condensing coil, that is extremely hot. Anytime you compress a fluid, and the air is a fluid, you get an increase in pressure and decrease in velocity and an increase in temperature. Because what's happening is you're taking those electrons that are orbiting around the outside of that nucleus and you're compressing their orbit. They have to give off their energy, so it gets hot. Well, that heat is what sets off the fuel, okay? In a diesel engine, you're compressing it to 22.5:1 compression ratio, and then you, well, it's already at the temperature that it would automatically ignite it. You wait on a diesel and so that you inject it at 1 second there, so that just as it's reaching top dead center, so that you, just before it reaches top dead center, you inject it, so that by the time that crankshaft breaks over top dead center there, that the flame is already propagating and the bonds are already breaking. They're oxidizing. They're melting. They're joining with the oxygen. They're breaking and rejoining with the oxygen. And what happens when you break those bonds? It gives off the heat. The fuel isn't what causes the air to that causes the piston to push down.